So for our final panel of day one of Earth Summit, we'll be hearing from the Smart Grid, Harnessing the Power of AI, which will be moderated by Prasanna from UC Berkeley. We'll be hearing from an incredible group of speakers that will be going live to discuss topics ranging from the electric grid to smart energy storage to solar power and how they are making a difference moving toward greater sustainability.
Okay, hello everyone. I'm Prasanna. I'm a PhD student at UC Berkeley, and I welcome you all to today's panel on the smart grid harnessing the power of AI. We have really great panelists today, and I'll be happy to introduce them. But let me first share my slides. Okay, I hope you can see my slides. So our first panelist is Lehman, who is the head of product management at STEM. Josh, can you say more about yourself and the work you do?
Yeah, absolutely. So yeah, as Harry said, I lead product management at STEM. STEM is an operator of energy storage systems. We operate fairly large scale energy storage systems, anywhere from 18 kilowatts up to several megawatts in size. We started off serving commercial and industrial customers, but now manage a bunch of hybrid power plants. And our focus is on making those projects successful. So we help project developers analyze, sell, build, and optimize the assets. So the key to our formula is what we call Athena, which is our artificial and machine learning optimization service, which provides automated control over energy storage systems in order to maximize the economic benefits of it.
Thank you, Josh. So our next panelist is Kristina Libby, who is the Chief Scientist Officer at Hypergiant. Kristina.
Thanks. Hi. So Hypergiant is an AI company. We're both a products and services business, and we focus a small amount of our time on the energy sector. But I have spent sort of significantly more time thinking about cybersecurity and energy and infrastructure and what the smart grid means and sort of the vulnerabilities and attacks there, particularly as we transition to a more energy integrated future. So that's what I'm excited to talk about. Thank you for having me.
Thank you, Kristina. Our next panelist is Kerri Devine, who is the Director of Engineering at Arcadia. So Kerri.
Hey, thanks for the intro, Harry. Nice to meet everyone. I'm excited to be here. So as he said, I'm the Director of Engineering at Arcadia, which is a platform connecting American consumers to clean energy, largely focused right now on community solar. We believe that consumers should be able to have access to clean energy no matter whether they rent, live in a home, have a high credit score. And so we try to connect users to clean energy through matching their clean energy usage with things like renewable energy certificates and connecting them to those community solar projects.
Thanks, Kerri. Our next and the final panelist is Dr. Jeremy Renshaw, who is the Senior Program Manager at the Electric Power Research Institute. And yeah, Jeremy.
All right, it's great to be here with this wonderful panel. I'm very excited to hear some of the insights from the other panelists. Some of the things that we're doing at EPRI are related to building an AI and electric power community. So we're looking at not just internally where we're developing AI and machine learning algorithms, but really building that entire community across all of the utilities around the world with AI communities. And then next, to be able to do that, we're putting together data sets that would be very useful for AI algorithm training. And we're building a number of tools internally, as well as sharing those externally. And finally, we're trying to help the power industry to better understand AI through training, workshops, and other events. So looking forward to hearing the rest of the items from the panel. Thank you.
Yeah, thank you, Jeremy. So for the questions that follow, we'll follow this order in which the panelists will answer the questions, starting with Joss, Kristina, Kerri, and then Jeremy. I'll stop my sharing and then we'll start with the first question, and we'll start with the questions where and why. So the first question is, where do you believe that AI, or commonly called artificial intelligence, has the most impact in the electric grids so far, and what's the future that you foresee? And the answer to this that you say about where you see the applications of AI in smart grids, also mention how do you think, or how do you rationalize or justify the necessity of machine learning or artificial intelligence in that particular application? Josh.
Sure. So as I mentioned in the intro, STEM really focuses on the optimization of energy storage. And the reason for that is that as the electric grid has modernized to become more of a bidirectional system, where consumers of energy also do produce some of their own energy. And as we have intermittent renewable energy sources like solar and wind, which are only sometimes available, storage becomes the flexible asset that can make those technologies successful and enable us to adopt more. The grid on its own is enabled to store energy, so the batteries that STEM controls provide that flexibility. And where machine learning and artificial intelligence come into play there is that they provide the mechanisms with which we can forecast electricity production and demand. We can do fault detection and many other things to make sure our systems stay healthy, and use that to drive the optimized operation of the storage system. So that's what's brought STEM to where we are today. Looking forward, I think the thing that I'm most excited about is uses around electric transportation. And as we electrify the transportation sector, we'll need more sophisticated models to manage electricity flows and to avoid extremely costly upgrades to the electrical grid, so that we can support massive amounts of charging infrastructure.
Great, Kristina.
Those are all wonderful points. I think the perspective that I'm really coming from is this, which is that it is an old system and it is broken and it needs to be updated, right? So like at the very base level, it's that like the system isn't actually serving what we need it to do. And so how do we make that better? Well, let's use the most advanced technology we can to make sure that we are creating a system that is not only going to serve us now, but going to serve us in the future. And there's a lot of political issues sort of in the way of us getting there. But I think one of the interesting things about machine learning and AI is that it's just going to become like an extremely obvious technology to use as we update. Like we can't do it without it. So it to me feels like it's kind of our only option. That it's not like there's sort of that we need to justify the use of the technology. We need to justify why this is sort of the immediate thing that we need to. I think it is one of the biggest, possibly the biggest security concerns from both a threat to our citizenry from outside players, but also from a sort of an extremely large climate change issue as well, right? So it's like the biggest defense priorities are all made clear in this issue.
Thanks, Kristina. And I think those points you told about climate change and then security and reliability and all those things are really important from the point of view of smart grid. And in fact, we'll come across a number of questions throughout this panel, which will focus specifically on those. But now we'll move to Kerri.
Yeah, strong agree, Kristina. I was actually going to make the point, Hari, that implicit in your question is that when we're trying to rationalize or justify it, it's, we're implicitly implying that we can build a smart grid without machine learning or AI. And to Kristina's point that the grid is old, it's important for us to understand exactly how antiquated it is. Our oldest power lines date back to the 1880s, and most of today's grid was built in the 50s and 60s with a 50-year life expectancy. So we're well overdue for an upgrade, and we're already falling behind. The US has more power outages than any other developed nation. And so it was designed when the grid was, just managing the flow of electricity from several centralized power plants across a few interconnections into homes. And humans were vastly responsible for the vast majority of balancing the grid. And so as we have more and more distributed resources operating at the grid edge and behind the meter, we now have what essentially amounts to millions of mini power plants, both generating and consuming electricity, that need to be coordinated. And so AI, to your point of, where has it operated so far? It's mostly operating to help with centralized grid management systems, transmission management, but I more and more see it moving to the grid edge. Think about rooftop solar panels, EV batteries, help optimize every aspect of those components, what they're made of, how they're made, when and where they interact with the grid, and when and where they interact with other systems on their grid. The other component there is AI is increasingly helping to decarbonize the grid, which isn't making it smart per se, but it's certainly helping to accelerate us to a grid that will scale for the next 50 years and beyond.
Definitely, Kerri. And I think the point you made about distributed resources and lots of renewable energy being pumped into the grid, and AI having the potential to manage a lot of resources simultaneously is a big plus point that AI has to be applied to in this field of smart grids. We'll move to Jeremy.
So first off, I would agree with all the other panelists. The grid, I would say, has served us well for many years, excluding extreme weather events like floods, hurricanes, fires, and so forth. The grid is actually 99.97% effective in terms of providing reliable electricity. So I would hesitate to jump on and say it hasn't been serving us well, but just because it's done well for the past 50 to 60 years doesn't mean it's going to continue. As several panelists already mentioned, we have significant penetration of solar, wind, and other distributed energy resources. So when we go from the old model of having a few very large power generation sources and lots of inertia on the grid, it's very easy to maintain a stable grid. However, in the future, when we're going to hundreds of thousands to millions of distributed energy sources and prosumers, people who are both producers and consumers of electricity at different periods of time in the day, along with grid storage, battery storage, as Josh mentioned, we have a grid that is infinitely more complicated in the future than it's been in the past. And so I don't think there's really a question in terms of the necessity of AI and machine learning. There's no way we'll be able to operate the grids of the future without it. So I don't think there's a question of if, it's really a question of when and how.
Great point, Jeremy. And yes, it's really a question of when and how, and having proven the efficacy of machine learning and AI, it's just when do we adopt it and how do we adopt it? This is a good point. We'll move to our next question. So this question is a lot on reliability. And as everybody of us here has been aware of the recent events, recent extreme weather events, as it was in Texas back a few months. So recently, with the effects of climate change, we have seen that extreme weather events have become more severe, and they have had disastrous impacts on the power grids, right? So how can we make our grids resilient to such events, and many of which are driven by climate change, right? So how can we make our grids resilient, and can AI play a role, and how and why? Josh.
Sure. Yeah, that's a great question, and I think really timely. We're thinking a lot about Texas these days, as I think anybody in the electric power sector is. And I think what we learned in Texas this winter, or a bunch of things, but one of them was that reliability is super important, and it's worth paying for, right? Because Texas did not have a capacity or reliability program. It really had a really tough winter for that reason. But we've also seen that severe weather can override whatever preconceived notion we had of what reliability means. I mean, I'm in Oakland, California, right? And this is a kind of virtually hosted out of LA, right? So, you know, we have public safety power shutoffs out here because of wildfire season, and no capacity market can really deal with that. But I think that what is common to the public safety power shutoffs and the Texas market in general is the fact that we are seeing that like large centralized transmission creates constraints on the system, and distributed generation can get us around that. So, you know, to the extent that AI plays a role again in distributed generation, and I'm obviously extremely biased in this regard, but you know, if it can make distributed storage and other distributed generation technologies available at the local level, then you can get around some of the failures of a centralized system.
Yeah, so the gist of the point that you mentioned is the distributed energy systems is the key, and instead of managing the whole grid from the central point, which might be prone to all these disasters, if we have distributed generation, that will ensure that we have reliability across the grid as compared to the centralized one.
Yep.
Right. We'll move to Kristina.
I don't have a lot to add to this point, or I mean, I think Josh said a lot of it very well. The only thing I would add is just the more data we have on all of it means that we will eventually be able to make smarter choices, right? And when we're talking about resilience in any capacity, right, we're just talking about increased optionality. And so that and the thing about lots of options is that you need to know which option to choose at which time, and that sort of decision making can be filled with a lot of errors. That the right data, sort of like taken smartly and cleaned and made effective, can help in making sort of that real-time decision making, particularly in cases like Texas, where the impact of a failure in resilience is actually the loss of lives, right? So in those moments of sort of escalated human concern, we see escalated moments of error. And so the more data that we have to sort of de-escalate those moments so that we have like a minimal amount of lives lost, I think is incredibly valuable. So that just sort of that little additional point.
Yeah, I do agree with the point of data, but I have a little follow-up question to that. If you have, so often the data corresponding to this extreme weather events are always scarce. Like we have extreme weathers, but extreme weather leading to the power failure, the data corresponding to that might be very less in many cases. So particularly, what kind of techniques do you foresee that can be applicable so that we can use the minimum data that we have and still make some difference in making the grid more resilient?
All right, so you're asking what we can do right now in order to make the grid more resilient?
No, as in like we have limited data corresponding to this extreme weather event. So possibly what I foresee and what you might have some additional points to it. So if we have some techniques that we can use this limited data in order to make the algorithms more robust so that they can be used in the case of extreme weather events, they will be very useful. That's what I wanted to mention.
I am not the right person to answer this question. I don't know if someone else would.
Yeah, possibly.
Yeah, I don't. Maybe Jeremy or Kerri or Josh has a little bit more nuance. It's a bit. It's a bit outside of my my areas.
No, we agree. So we'll move to Kerri.
Sure, I'll take a stab at it, but where I actually wanted to start was, with Texas. What used to be considered a 100-year storm is now happening every few years. And actually what happened in Texas in February happened exactly 10 years ago with a near identical scenario. And the failure there is that ERCOT, the body responsible for the reliability of the grid there, they were asked to weatherize natural gas wells and pipelines and didn't do it despite several warnings from federal regulators. And so we shouldn't have to wait for catastrophe to make updates to failing infrastructure. In the case in Texas, something like AI improved weather predictions could have given ERCOT earlier signal to increase reserve power, bring in backup power supply, and then longer term, with long-term climate models, we could better quantify how to expect things like extreme temperatures or wildfires to inform the investments that those utilities make. Something else that I wanted to highlight here is outside of extreme weather, the actual thing that's the most costly to utilities is actually tree maintenance. They spend over $1 billion a year managing trees and vegetation growth because the vast majority of most outages in the US are due to high winds, knocking down power lines. And so could we apply machine learning, for example, to satellite imagery to detect when vegetation growth is getting out of hand, and then use that data to operationalize utilities in those areas that are most at risk, and to minimize any potential catastrophe. And so I'll just say, like, the grid isn't prepared for climate catastrophe right now, but with AI, we can help prepare ourselves to mitigate those disasters.
Yeah, thanks, Kerri. I totally agree. We'll move to Jeremy.
Well, I suppose I owe Kerri $20 because that's a perfect segue into exactly what I wanted to talk about anyway. So checks in the mail. But speaking of satellite imagery, that is one of the best things that we could potentially do in the future. And it's one of the things that we're investigating right now at EPRI. We are looking at the potential for using multispectral and hyperspectral, which is very wideband imaging in terms of UV, visual, and infrared imaging of trees using satellites to be able to identify dead or decaying trees before they become a risk to power line assets. And not only that, but we found for, say, severe storms, there's the potential to work with a satellite company to, within a couple of hours, task a satellite and have the data over a very wide range versus sending out teams and teams of people for a period of 24 to 36 hours to assess the damage. So one of the two big drivers in the past that have made it difficult are the resolution, which has gone up exponentially. And we're now down to sub 30 centimeter resolution is capable, and cost. But the cost has gone down by a factor of about 10 every decade. So as that cost continues to go down with more and more satellites being put up in the sky, it makes it much easier, faster, more reliable, and more efficient to do vegetation management. So exactly as Kerri said, I just want to highlight that satellites will be our friend in the future, and they'll help us not only with things like resiliency, but also looking at wildfire risk. You can use the same satellites or sometimes different satellites with different capabilities to look at wildfire risks, as well as other things that we could do across the grid to improve resiliency. So not only that, but we can also use AI and machine learning to help us with outage forecasting and better understanding grid resiliency in terms of what components are starting to fail so that we can replace them before they do fail. One item in particular is transformers. They're a very low probability of failure, something like 0.03% per year. It's very low. But when a transformer does fail, it can have very catastrophic effects. I actually witnessed a transformer fail one time when I was driving home in the middle of a storm. There was a lightning bolt and I was stopped in traffic and it exploded right in front of me. It was both very terrible because it's very catastrophic, but also frankly pretty amazing to see a huge green fireball come out of this transformer. But obviously that is very bad for utility because they have to identify where it happens, send a crew out, replace it. And all of that during a storm is very difficult and challenging and can be dangerous. So there's a lot that AI and machine learning can do to help us prevent these types of scenarios, as well as respond to them faster and more effectively.
Thank you, Jeremy. So I think at this point of time, we have touched upon how AI and machine learning are important for smart grid, and also how it can be implemented in the case of reliability. So the next question is a bit philosophical, as in the question is, in your experience, are there any common misconceptions that power system operators have about the capabilities of machine learning? And are there any common misconceptions the machine learning community has about power systems? And how can we bridge the gap?
Sure. Yeah, it's a really good question. I think yeah, I'm probably more qualified to talk about the latter part of that. At STEM, we operate a full end-to-end industrial IoT system. So we have hardware on the site that's collecting meter data and equipment data, passing that up to our cloud, and we're building data integrations with market operators and with utility companies to bring in data from them too. And I think something I've noticed in working with the data science team at STEM is we will often be overconfident in the data itself, right? Just because data comes from a utility company or just because it comes from an electric meter that's sitting right there on site doesn't mean it's accurate, right? There's all sorts of installation errors that can happen. We've gone through processes with utilities where the utility took a couple of months to realize that, or to acknowledge that their meter was just wrong. They had a wrong scaling factor on a meter, and we're billing the customer incorrectly. But I mean, there is a whole field of what we call VEE, validation, editing, and estimation, and it's big business. And a lot of the large suppliers to utility companies have their own VEE solutions. And I think that's the first step in bridging that gap. One thing this question it's funny, earlier this week, I went a little bit down a rabbit's hole on Tidyverse, the GitHub project that has a bunch of data cleaning utilities in it. And I was trying to imagine what it would look like to have some sort of extension on that library focused on energy data cleaning. So anyway, maybe something for the next hackathon I'm in. But yeah, I think there's a bunch that we can do to fix up the underlying data, essentially.
Agreed, Joss. Moving on to Kristina.
I think one of the things, like one of the misperceptions that we have to overcome is just like where in the system, right? Like it's extremely complex, right? So where do you go? And I think there is not like an excessive amount of machine learning and AI specialists out there, right? Like there's just like not a huge resource, and there's a lot of like really sexy, cool places to go and work if that is your focus area, right? And so I think I think there are areas, right? Like nuclear power is really sexy at the moment, but then there are things like, going and sort of just like working on a legacy system it's not exciting. And so I think there sort of needs to be a better job of like communicating the importance of the grid, communicating the areas of where there is really interesting work to be done, and then compensating people more for that, and probably through some sort of like federal mechanism that makes like there has to be some sort of, and there has been, right? There's like a lot of movement from the Department of Energy. There is a lot of precedent setting about how important this issue is to society. But I think as happens on so many issues, that filtering that down to make it like, oh, you know what I want to dedicate my life to like, fixing the energy grid is not something that I hear people that I work with or that I'm engaging with talking about and being really excited in terms of a machine learning or sort of, broader AI as a category issue. So I think it's right. Like we have a conceptual problem. We have like a vision problem about getting people excited about this work, or even sort of around the importance of what the work is.
That's a very good point that you made, Kristina. We'll move to Kerri.
I just want to say I love calling nuclear sexy, Kristina. I used to work in the building automation industry. I would tell people that buildings are sexy all the time. But anyway, back to your question, Hari. If I'm being honest, I don't know that machine learning is generally in the lexicon of most power system operators. If I had to guess, I'd assume most of them think like machine learning is just some power hungry robot that's going to take over the world that they're just trying to plan and adapt for. So I guess my answer here is just, I hope that we can develop AI sustainably in concert with those system operators, to Kristina's point, like doing some education, ultimately to help them do their job better.
Right, and I think education is the big thing in order to bridge the gap, and there has to be awareness among both machine learning and power system researchers about each other's discipline, and that can bridge the gap, to say. Jeremy.
I'll start off with, boy, I love being on this panel with such great people, but they covered all the great points that were to be made. So it is hard to go last. So I'm going to change the question a little bit. Instead of misconceptions, I'm going to say, I'll answer the question of why are we not adopting this? And I heard nuclear power twice, which I love because I think it's exciting and sexy, but I've worked in it for a long time. I will say, to Kerri and Kristina's point, nuclear power, as well as the electric sector in general, doesn't speak AI. And conversely, AI doesn't speak electric power very well. So really, we have two communities that don't engage very much. And that lack of familiarity leads to a lack of trust. And so when we have AI and machine learning models that don't have very clear explainability, they're seen as a black box. And due to that lack of trust, that is really one of the big stumbling blocks to more widespread adoption. And so to be able to overcome this, there's a lot of different activities going on. Things like this panel, I think, are very helpful. Another thing that we're doing specifically at EPRI, we're working with the US Department of Energy on what's called Great with Data. It's an initiative to provide AI and machine learning training to power industry experts, as well as working with universities and other organizations to really provide the training and resources at all levels, whether it's within universities for the upcoming students, or to that person who's worked in the same job for 30 years and knows that one area really well, but to be able to learn more about AI, machine learning, become more familiar, gain the trust to be able to start using these systems and technologies more widely within the industry.
Totally agree, Jeremy. So we'll now move on to the panelist specific questions. And so these questions will be directed to some particular panelists, but if others have some inputs, feel free to speak up. So my first question will be for Joss. So the question is, with so many IoT devices and smart sensors that are available and are collecting the data to enable machine learning implementation in smart grids, so how do you deal with the big data challenges, particularly big data infrastructures and big data infrastructure, streaming and storage issues? So how do you deal with these issues? And for example, like if you have cloud technologies, what kind of challenges you have encountered in this kind of areas?
Sure. Yeah. So I think there's two things there. One is what technologies do we use, and second is how do we choose how to use them, right? So we're on AWS, and we use a number of their native services and all of our incoming data. We operate, for the record, about a few hundred, about 700, almost 800 sites right now, which are in real time collecting data from a variety of devices at each site. So all told, we've taken about a terabyte of data every day, a little more than that now. And that's pushed into a combination of hot, warm, cold data stores on AWS. So the challenges that come with that, and the way in this kind of the second part of this is, how do we orchestrate those services to work for us? It's a matter of making that data available, processing that data, storing it, and making it available at a reasonable cost, right? That's the hardest thing for us, because if we wanted to, we could pretty much we just give all of our profits to AWS. That's a very easy thing to do. And our account manager probably wouldn't mind it. But the trick for us is, and what we've found over and over again is, just start with the end in mind. So to think about, what exactly would be the end use case for your data. What kind of variables will you use in forecasting and fault detection, other machine learning applications? What do we need for our user interface? And then track all the way back down to, okay, that means we need to have this in our data store, we need to have this mapping on our edge controller, and we need to interact with these registers on the end device. So it's a lot of mapping data flows, but it it pays for itself, because the alternative, which we've seen, I've seen some other smart grid companies do this, is that we're just going to take every data point from every edge device, every 2 seconds or something like that. And they just end up with a ton of data and a ton of costs, and it's not manageable for them to work with it. So it's a matter of efficiency, and efficiency comes from being really specific about your use cases and what you need.
Thanks, Josh. And I think it's really exciting to hear from you about how industry, particularly STEM, uses different machine learning techniques in the field of smart grids. My next question is for Kristina, and the question is on cybersecurity. So the question is, as energy supply and the entire energy system are part of country's critical infrastructure, how cybersecurity is evolving, and how vulnerable our current power system is with the introduction of AI and machine learning? And are there any regulatory authority for oversight on data and security of and data protection of these systems?
So I think it's a pretty double-edged sword of what is the bigger threat to our electrical grid is VITs, climate change and sort of these superstorms, right, that we have very little control over, or is it foreign actors or cyber criminals who want to wreak a little bit of havoc? So everyone is in our power grid, right? China, Russia, Israel, everyone is in there. And so so it's fundamentally flawed from that perspective, and we need to think about how to make it more resilient. Obviously, one way to think about resilience is to sort of enhance the technology, to have stronger machine learning and ultimately AI capabilities in the grid as protective defensive mechanisms. But there are challenges with that as well. Like, technology isn't the solution to the fact that a bunch of foreign actors can take out our electrical grids if they want to. Now, it's a big power move, right? It's really risky. The chances of it happening is relatively small, just because the retaliation would be so great if properly identified. But that being said, it's still a chance that exists. And so so we need to think about it. We need to have a strategy for it. We need to have technology for it. There is a lot of money being put against this problem. So the Department of Defense is thinking about it. DARPA is working on solutions. The Department of Energy is working on solutions. But as with all things, we need to decide what is the role that technology plays, and then what is the role that humanity plays, right? And so a lot of negating the risk to the electrical grid from a cybersecurity perspective is having really great political relations, right? So that we're not using those bargaining chips. At the same time, it's about building something that's stronger and more defensible. But with all technology, right? It's like you ratchet up here and then someone figures out what to do about it, and you ratchet it and you ratchet it and ratchet it, right? So it is something that structurally, from a great powers perspective, is always at risk. So yes, obviously, there's great technology that we can use to make it better. There is also so many other factors that go into protecting the safety of people's lives. But the point everyone should know, if you don't know it, is that it's already compromised. So what we're really doing is thinking about all of the criminals are already in my house. Are they going to do something bad, right? That's the scenario we're in. We're not we need better locks so people don't get in. And that's a place that it would be better if we weren't already sitting in.
Thanks, Kristina. Next question is for Kerri, and it's on renewable energy and their penetration into smart grids. So the question is, what are some of the biggest challenges that power system operators face today in managing low carbon or renewable energy based electric grids or microgrids? And what are the biggest opportunities for machine learning in helping to address these challenges?
Sure thing. So I mean, The biggest challenge for low carbon grids for operators continues to be being able to match generation to demand. Let's take California, for example, where solar generation in the middle of the day often far exceeds demand, causing California to export that energy at a loss, and then leads to carbon-free power production, less carbon-free power production than theoretically possible. And so storage is the obvious solution there, as Josh talked about, for managing oversupply. But there's been another recent research avenue that I'm really excited about. So I don't know if you guys caught this, but last Earth Day, Google announced a carbon-aware platform in which they actually are shifting computational loads, since information travels, at the speed of light, not only temporally but also geographically between their data centers. So in essence, they're working harder where and when the sun shines brightest and the wind blows hardest. So the opportunity for machine learning and AI is twofold here. The further out we can predict the carbon intensity of the local electrical grid through things like weather predictions, power generation outputs, the better the grid operators can actually plan to avoid having to spin up dirty peaker plants in the middle of the day. And then also the better that large electricity consumers like data centers and industrial manufacturing plants can plan on when to use electricity to both save money and time and reduce their own carbon emissions.
Thanks, Kerri. So yeah, next question is for Jeremy, and it's a bit technical about, so the question is, what challenges do you see in electric utilities that AI can potentially solve? And I think most of your current projects are related to that. So so what are the current projects that you are working on involving AI and electric power, especially related to smart grids?
Okay, so I wouldn't go so far as to say what challenges can't AI help solve, but there are certainly a huge number. Right now within EPRI, across the entire institute, we have about 50 or 60 active projects using AI and machine learning. So I'm not going to go into all of those. Certainly we wouldn't have anywhere close to enough time, but there are a number of things that we can do, and a couple of these things were brought up already. I know Kerri mentioned earlier looking at grid integrated buildings. This is one that we're working on right now, as well as several other organizations. And this is really interesting in that by controlling about 25% of a building's systems, you can reduce the energy usage of that building by 30 or 40%. So you don't have to control a large percentage of the building to see really large impacts. And if we multiply that by the millions of buildings around the world and then start integrating that into smart homes or grid integrated homes, where you can start buying and selling energy, buy when it's low, sell when it's high, or reduce your energy usage when it's high, all of that again makes the grid more complex, but also allows us, as the other panelists have mentioned already, to be able to flatten the duck curve or flatten the load during peak times to be able to more effectively use low carbon or zero carbon energy resources. So I think all of that is very helpful, but not only that, there are so many large data sets that we can use to help us in this journey. So I mentioned that EPRI is doing a large number of AI related projects. We're also pulling together large data sets. We're calling them the EPRI 10, the 10 most valuable data sets for the electric power industry. If you go to ai.epri.com, they're all available there. You can look at those, contact us to be able to get access to those. But just these are really the tip of the iceberg. If you look at one of those data sets, which is the advanced metering infrastructure or AMI data set, we've identified 81 different use cases for that set of data when combined with either feeder data, circuit level data, forecasting data, or other data sets, to where we can start to better inform what we're doing on the grid to be able to be more effective, more resilient, have lower carbon emissions, as well as be safer. So we need to put all of this data to work to be able to be effective, and it's really going to take a team effort. There are so many different use cases and so many things that we can work on together to be able to solve these challenges that no one organization is going to be able to do it together. So I think there's going to be a very high importance for teaming and collaboration across the entire AI and electric power community to be able to address these challenges.
I would just like to add on, sorry, I'd just like to add on to what Jeremy just said, which I think is how important it's going to be to create like more collective action and like more coherence among a disparate group of people who aren't particularly concerned about this. I think there's like a real like a public education or like a public knowledge question, but like that's taking it a little bit too far, right? It's like, I don't know how concerned the public needs to be about this issue, but there's that sort of like in between of attracting people to work on this issue and like getting people more excited about it and engaged, and then creating collaboration. And I feel like part of that is vision based, right? Which is like what is the energy future that we want to get to? Like, how do we want this to work? Who needs to do what and where and why? And I feel like that roadmap, if it's out there, is I hope it's out there, but if it's out there, it's not something that I am seeing people align to. And so there needs to be some sort of a fix in before we even have technical fixes. We need sort of a social fix to the conversation.
And Kristina, I couldn't agree more. Thanks for jumping in there. I think that's very important. And I think one of the ways, and Kerri mentioned this, if we can find a win for everyone, where the utility wins because they're not turning on their expensive peaker plants, the customer wins because their power bill is lower and they're saving carbon emissions, and the AI company wins because they're selling a product. If we can find collaborations like that, where there's a win involved for everyone, including the earth, I think that's when we really reach that critical mass of people wanting to get involved, people excited about where we can go. And that's when we really make the big change. So thanks a lot, Kristina. Completely agree.
Yeah, thanks so much, Kristina, for the inputs. And I think this all make really good sense. So now we'll have two last questions, and for these questions we'll again go in round robin order, and we'll start with Josh, Kristina, then Kerri, and then Jeremy. And the question is how. So we have people from industry sector in this panel, and we have Jeremy, who is from EPRI, which is more kind of a research institute. So the question is, how can the industry sector, which manages most of the electric grids today, can foster data sharing and research initiatives on AI and smart grids in collaboration with academia and governmental research labs? Josh.
Yeah, it's a really good question. I think it's something that I agree. It would be wonderful to do more of. There's, I think, something that that we struggle with at STEM is a lack of standardization for a lot of data that's out there about the smart grid. Every time we go and integrate with a new inverter or a new battery or another new piece of equipment, it seems like we have a whole new interface to learn and a whole new set of alerts and alarms and other things that we need to take up. And that's unstructured data that we need to normalize and fit those into the framework that we have. So there is some good progress being made. I should say a colleague of mine, David Earhart, sits on a few working committees for SunSpec and some other bodies that are trying to organize and come up with standards with how we structure data. So that's, I think, the first thing we need to do. And then once we have that, you get into, okay, well, what are the agreements under which we could share this data with each other? And for us, our data is split between commercial, industrial, customer load data, which is data that they don't want us sharing, and independent power producers, so essentially power plant production data for large front-of-the-meter storage and solar plus storage systems. And that data is, you can kind of figure it out if you look at bids and wholesale market clearings, and it's there. It's a little bit scattershot, but I would think that I do think that there's opportunity for the markets to make that data a little more visible and a little easier to work with, because it's essentially there if you work hard enough right now. But I think we can lower the bar.
I'm going to take sort of a two-pronged different response to that as well, which is I think one of the areas the industry fails is actually looking at academia, right? Like if there are a lot of amazing research projects that never see the light of day. And so if we had fewer entrepreneurs like go out there and feel like they had the right answer, and maybe more licensing or more agreements with academia about how to take what's being worked on, or sort of like thought experiment ideas or ideas that are fully baked, and actually like productize and commercialize those ideas. I think there's a huge opportunity there, and I don't think we do that very well. And so I think that's a strong path for industry. The other thing that I don't know if y'all read Bill Gates's book recently. It was very hot, so I read it like everyone else too. He made a good argument in relation to energy, which is that it's like actually very hard for sort of regular people or people who aren't like deeply steeped in the industry to understand what is and what isn't impactful. And I think like this is true of all of the information that we see. And then it would be great to have some sort of just, I think the point Josh was making, right? More standardization of where we should put our time and resources, so that from like an industry perspective, particularly if you're someone like us, right? You have a lot of people who work for you who are capable of doing interesting based work, maybe even hobby based work, but don't know exactly where to spend their time and energy. And that was really the point that Bill Gates made, that I thought is an important point, is we have this conversation.
Thanks, Kristina. Kerri, what do you think?
Yeah, I mean, one of our hardest jobs at Arcadia is actually customer education, getting people to understand what a kilowatt hour is and how we actually are able to connect them to community solar projects. But my answer is focused specifically on utility data. That's what a lot of our focus is on at Arcadia. The first step is actually convincing utilities that the data doesn't belong to them, it belongs to their customers. As of late 2018, utilities had installed 90 million smart meters, and yet the data from those meters is largely only available to the utility by design. They're afraid of losing their monopoly stronghold over their customers, right? And so what works to a degree somewhat is regulation standardization, as you heard. There are a few states that have required utilities to make that data accessible. The White House launched an energy data standardization effort back in 2011 called Green Button, with middling levels of success. So we have a long way to go, but this is where actually private industry can step in. So like at Arcadia, we are writing web scrapers on the customer's behalf to get that data and serve it up to them to be able to offer them insights that the utility is just not incentivized to give to them. And so we're starting to see utilities start to come around, but we'll need to help prove the value to them by making that data available, normalizing it, and then we can rapidly accelerate the pace of innovation.
Totally agree, Kerri. Jeremy, what's your opinion?
Yeah, and I've heard a common theme among all the panelists, and I really want to emphasize it. It's all about the data. If we don't get the data, we can't do anything with it. It's really hard to truly estimate, even with synthetic data, all of the conditions that could be out there. I would also say that while we've talked a lot about the AMI data, that's only a small fraction of the overall data the utility has. They have various sensor data, they have operational data in their transmission lines and their power plants and all over the place. A lot of it, as Josh mentioned, is unstructured data. I mentioned earlier in the panel that EPRI is collecting these data sets, one of which is power plant maintenance work orders. We have 27 million maintenance work orders that are available. The problem is they're all unstructured data. They're just people writing down in the work orders different things. And to be able to release those out to the AI community, we have to be able to anonymize that. And we're not going to have somebody go through and cross out all the names in 27 million work orders. It's just not feasible. We can go through with AI to try and manually remove those, but how can we verify that we haven't released anything that shouldn't have been released? Because people can write anything in the fields. They can write Jack broke the XYZ widget. Well, you don't want Jack's name to be in there. But if that company is the only one that calls a particular component the XYZ widget, well, you can't have that in there either, because then it gives away what plant the data was taken from. So there's a lot that goes into being able to cleanse and anonymize the data for appropriate sharing outside of the utility. And it's not only just the utility plant staff, but also the people. So when we get into AMI data, we don't want to be sharing, how much energy was Hari using at what times a day, because it's dangerous, because if I can see that Hari's not home at this time of day, well, guess what? I can break in and steal things from his house. So there's a lot of sensitivity around the data, and to be able to anonymize it, cleanse it, and make sure that we can't gather where it came from to protect people's personally identifiable information. So that's a big effort that we're going through at EPRI right now. We're trying to make as much data available as we can to the AI community, but it's not just about the data. We also have to have the right events within the data. You can have, I mentioned earlier, transformers, which are very highly reliable. You can have 10 years of good data on a transformer, but it doesn't help very much for your AI algorithm if you don't have any failures, or maybe only one in your data, because essentially it's the same data point repeated 10 million or 100 million or 10 billion times, and that doesn't really help either. So it's getting enough data, getting the right data, anonymizing it, cleansing it, and then making it available to those who need it. So it's a big ask. We're trying to get there, but it's a long road from here to there.
Thanks, Jeremy. So the final question for the panel today, and the question is about how can we build interest among researchers and people to do research at the intersection of AI and machine learning and smart grids. So the question is, what advice would you give to those who come from outside the power industry? Let's say someone doing core machine learning or AI, but would like to collaborate with the power industry, or otherwise make sure that their work is deployed in the power industry. So what would be your advice for them? Just
Sure. Yeah. So a couple of things. First, I want to touch on something, with the last discussion we were having about making data available and normalized and accessible. I think something that I've realized is really important when we do that is to make sure we document the chain of custody of the data and who's made what kind of edits and manipulations to it. Because yes, we all want good, clean data, but that requires whoever's doing that normalization to make certain assumptions, and certain nuances of the data can be lost in that. So anyway, there's a trade-off there, of course, but I think having the chain of custody at least lets you know who's had their hands on it. Anyway, that being said, I think to your question, Harry, Kerri made the point earlier about how we have to educate customers a lot on what is a kilowatt, what is a kilowatt hour, what are all these things, what's a feeder, what's a substation. There's a whole bunch of nuance and for lack of a better word, just nerdiness about the energy industry, which is why I love it and why I work in it. But I understand that my family and my fiance and other people don't want to hear about it all the time, right? So I think that people coming into the energy industry who want to interact with it, there is a wealth of really interesting stuff happening. The thing that I see a lot of companies doing that I try to make them aware of is coming in with a software-only solution that is applicable for certain services, but it's a hard road, I think, in the energy industry because of all the nuance. You typically, in order to provide your customer with the value that they will need to have some sort of a services arm or some sort of manual operations team that's there to do support. And they're essentially super users of your tools, right? We have an operations team which is essentially super users of the Athena platform, and they are making our customers successful. So it's not blanket, you always have to have an operations team, but I think it is something that is really important. And the way you figure out whether you need that is you need to take a step back and say, okay, what is the full product that my customer is really purchasing? Because it's not just my solution, right? There's always more to it. And for us, I mean, even for me, right, it's not just storage, it's the whole suite of distributed resources. And figure out what you need to do to make sure they get that whole product. So I've gone on a little longer than I should have, but that's my soapbox.
Kristina.
I do not have a lot to offer on this question. I would say probably go work for everyone else who is on the call. I think if you want to find your way into this sector and you want to do smart work, you will find a way in, and that there are opportunities. And we know that this is a huge challenge, and we know that we have to figure it out in the face of like dual security risks, or sort of like, that's how I think of them, right? Security risks. And so like there is a willingness to figure this out in interesting ways. So just go, try, do it, find people, talk to people, and you'll find your way.
Totally. Kerri.
Yeah, thanks, Kristina. Yes, we are hiring at Arcadia, but anyway, I'll just add that look, climate change is here and solving it urgently requires a smart grid and will require diverse perspectives and experience. So if you're passionate about building a cleaner, more resilient future, there's a place for you in your research. Look, there was $17 billion invested last year into climate tech, the largest on record, even despite a global pandemic. So think about which areas in the space are exciting to you. Is it the devices operating at the grid edge, the grid itself, consumer behavior? Look into the companies operating in those spaces and start there. I also recommend leaning into different accelerators or fellowships. I'll make a selfless plug for the Clean Energy Institute. They specifically look for industry switchers that want to contribute to the clean energy transition. But there are so many problems out there that need solving. And so I'm sure there is a place for you in your work.
Totally. Jeremy, what do you think?
I completely agree. There are so many opportunities in AI and electric power. I mean, the AI industry is $1 trillion industry. Electric power is $1 trillion industry. There are many opportunities to get involved, to get engaged, many different companies around the world. Anywhere you are, there's an AI or an electric power company near you you can get involved in, work for, work with. If you want to get involved in what we're doing at EPRI, just go to ai.epri.com. We have various training, various other things you can get involved in for free. And we'd love to invite more people to get involved with us to really make a difference going forward. So thank you, everyone. Have a wonderful night.
Yeah, thank you, everyone. And I think with this panel, we discussed a lot about different facets of smart grids and AI, and how AI is a valuable tool in smart grids in the goal of making the grids more smarter and more reliable and more robust. And we also discussed about how can we share data across industries. We can have trust in the data. We can have explainability of the AI model that is being implemented. We also discussed about the education and training that has to be done in order to create an awareness between machine learning AI researchers and power system researchers. And we also discussed about different opportunities that people outside of power systems or smart grid who are core machine learning or AI people can use to leverage their expertise in this field. And with this, we have come to an end. And I really want to thank all the panelists for all their inputs. And yeah, thank you so much. Have a great evening.